Hi everyone, welcome to chemistry lesson number 2. Today's topic is simple distillation. Let's have a look on the learning objectives. Students will be able to learn about the method to separate and purify a solvent from a solution, equipment and steps involved in simple distillation, and also learn how to check the purity of a substance by the help of boiling points. Simple distillation can be defined as simple distillation is used to separate a pure substance from a solution. An experiment cannot be understood without visualization. So let's have a look, how does this experiment work? In simple distillation, the condenser is cooled with the running water. Heat is applied to the mixture to be distilled, which is in the distillation flask. The mixture begins to boil and the vapors rises up. The thermometer measures the temperature of the hot vapors. Temperature rises. The vapor temperature remains steady as a pure liquid is distilled. Then the vapor condenses back to the liquid when they are cooled into the condenser. The purified liquid is collected in the receiver. Non-volatile components remain in the flask. That's how the process works. You can always pause the video and you can try to identify the equipment which has been used in this particular experiment by taking some help from your first video lesson of experimental chemistry. Now let's have a look at the simple distillation process of the carbonated drinks shared by the Cambridge International Examination.
Separating a mixture of liquids is the perfect job for distillation. In this experiment, a carbonated drink is going to be distilled.
Here again, we have explained the whole set of equipment that will be used in the process of the simple distillation. For example, a stand, a clamp, that is used to hold the apparatus. Then a conical flask is also being used instead of a distillation flask. Rubber stopper, a thermometer, a carbonated drink, a hot plate. In the previous animated video, you have seen that we were doing direct heating. Direct heating is suitable in case we are using a mixture which is not flammable at all. For example, salt water. But when we are dealing with the carbonated drinks or organic solvents, it's important to be careful, and for that, hot plates are preferred instead of direct heating. Ice water along with the test tube will work as a condenser.
First, the ice baths are prepared. These act as the condensers. There should be no ice inside the test tubes. To one of the test tubes, 50 centimeters cubed of lime water is added. Lime water can be easily disturbed and can become cloudy really easily. About 100 centimeters cubed of the carbonated drink is added to the conical flask. A stopper and thermometer are added and secured tightly. To stop the gases escaping, the tubing is securely fastened. The free end of the tube is placed into the lime water solution. Now the hot plate is turned on and the carbonated drink is heated. Bubbles should start to appear coming from the tube and into the lime water solution.
Remember, the bubbles which are coming out and mixing with the lime water are the bubbles of the carbon dioxide gas. And how do you know that? Because you are dealing with the fizzy drinks, in which carbon dioxide is the most important factor.
The solution becomes cloudy.
When the solution becomes cloudy, that confirms that carbon dioxide is reacting with the lime water and turning into methane. That confirms the presence of the carbon dioxide.
Now the temperature is measured and the time recorded. The gas being produced is carbon dioxide. The temperature at which it was given off from the solution was 30 degrees C. The carbon dioxide reacts with the lime water, calcium hydroxide, to produce calcium carbonate as a solid, which is why the solution becomes cloudy. Using lime water is a good way to test for carbon dioxide. The solution should be heated for a further 3 minutes at the same temperature. Now the water baths are quickly swapped. The test tube in the second ice bath is empty. The heat is now increased so that the temperature rises steadily. Vapors.
When the temperature starts rising again, that means all of the carbon dioxide has been removed from the mixture. And now, the component which will be separated will be a new or any other component present in the mixture.
This will start to come out of the solution, and to test for these, a wafting test is performed. The vapours are wafted towards the scientist. The vapours are hot and should not be directly inhaled. The vapours are the flavourings that are present in the carbonated drink. These food flavourings are esters and are low boiling point liquids. The time and the temperature is recorded when a specific smell is identified. The heat is increased so that the temperature rises steadily. Between 90 and 100 degrees C, a colourless liquid appears. The carbonated drink is allowed to boil gently until enough of the colourless solution has been collected. In this experiment, 3 components from the carbonated drink have been identified: carbon dioxide, food flavourings, and water.
Video and you noted down the 3 components that are the process of simple distillation. Now let's have a look at some questions. The very first question we will be looking at is, in the distillation of a carbonated drink, what is the function of the lime water? To absorb impurities produced in the distillation, it reacts with the carbon dioxide produced from the drink, to trap the esters produced from the drink, or to react with an oxygen left in the conical flask. What do you think? It reacts with the carbon dioxide produced from the drink. Let's check the answer. That is the correct one. Next, chemically, what is lime water? Calcium hydroxide, calcium carbonate, calcium chloride, or calcium nitrate? Think for a moment or go back into the video and see what is the formula for lime water. I think it would be calcium hydroxide. Check. That is the right answer. Why are the esters produced not collected as liquids in the experiment? Because their boiling points are too high, because they are present in small quantities and so cannot be collected, because they are dangerous in the liquid form, because they are gases, not liquids at room temperature. Because they are present in small quantities and so cannot be collected. Carbon dioxide changes from solid state directly to the gaseous state without displaying a liquid phase. What is the phenomena called? Sublimation, distillation, boiling, and evaporation. Sublime solids are the ones which directly change into the gaseous state from a solid state without undergoing into the liquid state. So sublimation would be the right answer. Next question is, once the distillation of a fizzy drink is complete, what is the residue left in the distillation flask not likely to contain? Esters, sugars, high boiling point decomposition products, or food coloring? Esters, Let's check the answer. That is the correct one. Ethanol, boiling point 780 centigrade, is separated from an aqueous ethanol mixture using a simple distillation apparatus. Place the steps of the procedure in the correct order. You can pause the video and select the steps you want to place in the correct order. So let's see what is the correct sequence will be. Number 1. A mixture of ethanol and water is placed in a round water flask. The ethanol vapor is cool and condensed. Can this be an option? No. Once the mixture is added, the mixture is heated. The mixture starts heating, then it goes rise to evaporation. Vapors will be produced. When the vapors cool down and condense, the vapors produce again. Let's see our answers are right or wrong. So these are the correct answers. So let's have a look what we have studied today. We did study about the mechanism of distillation and the distillation of the carbonated drinks with the help of the resources of Cambridge International. I hope you liked the lesson. We'll see you in the next class. Thank you. Take care.